All right, it's 10:40. Let's get started. First, I'd like to thank the conference organizers for giving me the opportunity today to speak to you and for each of you taking the time to attend this session. I want to say that there will be code and fine print on these slides, and so if you're at the back of the room, the slides are available on SCAD right now for you to follow along if you would like. My name is Bryant, and I'm the Chief of Research at Phylum. If you're unfamiliar with us, our automated platform monitors 7 open source ecosystems: NPM, PyPI, Crates.io, Maven Central, RubyGems, NuGet, and Golang. As soon as a package is published, Phylum downloads and analyzes the package for suspicious and malicious behaviors. To date, we have over 40 million packages analyzed and stored across these 7 ecosystems over the past few years. And today's talk is a sequel to the one that I gave this past June at B-Sides in San Antonio. There, I gave the complete backstory of the Phylum research team's journey with these threat actors over the course of the previous year. As a brief recap, in June 2023, Phylum's automated platform detected a suspicious package that we found to be from a very sophisticated but unknown to us at the time threat actor, and we published our findings on our research blog. The following month, GitHub security operations team independently confirmed that the perpetrators were from the Lazarus Group, a colloquial term for North Korean state-sponsored activity. From that point on, the Phylum research team tracked scores of packages across various campaigns that continue to this day. Some of these packages have been pulled from NPM as security holding packages. Others were unpublished by the attackers themselves, in many cases within a matter of hours or minutes after initial publication. One particular package that Phylum has from these campaigns was only in the wild for 90 seconds. And so to update you on this summer's new developments, I'll start with a package that we downloaded 5 weeks ago, moments after it was published. Heart Hat Cookie is an NPM package from a Lazarus Group campaign that started in the middle of December 2023. Here's a file listing for that package. Heart Hat Cookie is a Trojanized clone of the legitimate NPM package config version 3.3.9, as you can see from this diff. The 8 files in blue are identical between both packages. The 2 files in green, deference.js and pk.json, are new in the Heart Hat Cookie package, and the package.json file in yellow has been modified. I'll walk through the attack chain in each of these 3 files, starting with the package.json file, then deference.js, and finally pk.json. It's important to note here that the legitimate file defer.js, listed directly above deference.js, contains a couple of function prototypes and exports for the legitimate package config, but no other immediately executable code. So looking at the diff between the 2 package.json files, we find that the name and version have been changed, and this is a bare necessity in NPM to distinguish between the namespaces of 2 packages. The attack properly begins with the additional pre-install script. Pre-install scripts in NPM run prior to installation, and so an npm install Heart Hat Cookie will immediately execute the contents of the deference.js file and then delete that file. Deference.js has about 80 lines of code, most of which is a copy of the code in the original defer.js, presumably to make deference.js appear somewhat legitimate. After removing all that copied code, we find the following. At the top, 3 imports: operating system and file system functions. The 3rd import is for process execution. The next, 2 variable declarations. First, the variable OS type stores the operating system type for the host machine. Second, the data variable stores a string, which may be difficult to read right now, so I'll pretty print that in a moment. But the remainder of the block of executable code is run by the pre-install hook. First, it checks the OS type to see if it's running Windows NT, and if so, it writes the string found in data to a file named package.bat, which is then executed and deleted with the unlink command. Now, since I'm at a Linux Foundation sponsored conference, I'll add here that we've seen this attack pattern in other packages from this campaign that also check for Linux, that also check for Mac OS with the appropriate modifications, but I chose this example for simplicity in the interest of time. So the entire purpose of deference.js is to spawn and run package.bat. So let's take a look at that. The first thing to notice about package.bat is that it suppresses all output with echo off and redirecting all errors and outputs to null. Next, it then curls a server at a hard-coded IP address to get the resource at user/modify.asp, writing the output to a file named temp.b. If you were at this point to inspect temp.b, you'd find a Microsoft DLL file header. Next, temp.b is renamed to package.db. And then run DLL32 is called on package.db to execute the contents of the exported function RTL stackdb stack add with the two parameters SSMY and 4683. And this is really the upshot for the hard hat cookie package. The rest is just more cleanup. Now that package.db has been executed, it's deleted. And finally, package.bat checks for the existence of pk.json, which you will recall was the other additional file in the hard hat cookie package. Because this file obviously exists, the original package.json is deleted, and pk.json is renamed to package.json, effectively replacing the original package.json with the contents of pk.json. Inspecting the contents of pk.json, we find that the only difference is that the pre-install script has been deleted. So to recap, the pre-install script, deference.js, package.bat, package.db, and pk.json are all gone. The only thing that remains is whatever was the result of calling whatever run DLL32 left behind. If you were to diff the install hard hat cookie package with the legitimate config package, you'd find that these are identical. And so, a few observations. First, this behavior may seem innocuous to some. There isn't any malware present in the package itself. You won't find any of these file hashes in VirusTotal, for example. However, none of this passes the smell test. All of the files that eventually aid in the execution of the downloaded DLL are completely removed as if nothing suspicious has happened. And as a final observation, this behavior is not within the purview of traditional vulnerability scanning. There aren't any CVEs associated with this behavior. But aside from these observations, some reasonable questions remain unanswered. First, who would ever download this package? It seems highly unlikely that anyone would be fooled by hard hat cookie, especially if they even took the briefest perusal of the code inside. Phylum's success has largely been predicated on the fact that virtually no one does actually review the source code before they install it. We all download code from strangers on the internet. So next, who exactly is responsible for this package? What's their motive? Cui bono? Finally, how prevalent is this activity? Is this just a one-off? Well, the answer to the first question of who in their right mind would install hard hat cookie is virtually no one, except the intended target. The threat actor who published hard hat cookie employed a sophisticated social engineering campaign targeting one or more developers with a job offer. Our company has looked at your LinkedIn profile, and we think you have the skills to become our next senior software engineer at a handsome salary. Our hiring manager will happily meet you online if you will but download and install this repo for a quick coding exercise during the interview. Phylum has actually heard from software developers who've been victims of this attack. For example, this developer who found out just in time, I'll read the quote at the bottom. They told me that it is for coding interview software that I have to install, but before I do it, I found your warning and also read article and I resend email, but there is no response from their side. Well, thank you, sir, for saving me, and lots of job seekers, thank you again, sir. Others have reached out to us, but only after they've been victimized. For the second question of who benefits, based on the analysis of the hard-coded IP address in the curl command and the binary dropped by the DLL, this activity has been attributed to Contagious Interview, a subgroup of the Lazarus group. Contagious Interview's motive is stealing developers' cryptocurrency and anything else of value off of the targeted developer's machine. According to a recent UN report that Phylum contributed to, North Korea has stolen approximately $3 billion worth of cryptocurrency that they launder to pay for their weapons program in circumvention of almost a dozen UN resolutions. And finally, as to the third question of prevalence, this activity has been seen steadily over the past 3 months. The packages listed here are a sample over this past summer of some of the packages that Phylum has discovered from Contagious Interview and also Moonstone Sleet, another Lazarus Group threat actor. All these packages are different from one another. Sometimes the differences are slight. For example, a change in the query parameter in the curl command or the function name and parameters passed to the call to run DLL32. Other packages are based on completely different legitimate packages like config, but with far more files, which help the attacker to hide in the noise. Some of these packages are more complicated and employ more sophisticated tactics such as code obfuscation and encryption, but that would take us more time to unravel. So in conclusion, it's critical that we understand the threats that are attacking the open source software community. These attacks are low risk, high reward propositions for the attackers. The barrier to entry is low, and deterrence for this activity is virtually non-existent. Nation state actors are also sophisticated, persistent, well-resourced, not to mention motivated. And most critically, developers. Developers are the target, not the software. Obviously, the target of a social engineering campaign puts a particular developer at a direct risk, and that could be any of us. But also indirectly, legitimate developers are at risk because these malicious attackers are masquerading as the developers of these cloned repos by preserving the persona identifiers of the original code owners in the Trojanized package. Next, traditional SCA solutions, vulnerability scans, malware scans, they're necessary, but they're not sufficient. Of all the malware that Phylum reported in the first quarter of this year, 82% were never reported as a GitHub malware advisory. None of them had a CVE associated with them, but 100% of them did something bad to the victim. So by all means, keep scanning for vulnerabilities, keep scanning for malware, but recognize that these sophisticated attacks evade those defenses, and they're successful. So if you're interested to learn more about our findings, you can follow us at blog.phylum.io/research to learn more details about these attacks, as well as other research, such as our recent analysis of the proliferation of spam packages on NPM. Thank you for your time, and I'll take any questions. Yes?
How do you identify what the base packages that's being lived in the scale?
So the question is, how do we identify the base packages? Right now, it's very manual. So I told you that there were the files that were in common. Usually you can find some unique strings that you can go search on GitHub or something like that for, or we can, a lot of what you saw is our internal tooling. We can do full text search on these packages and go find that little thread to pull. And then usually I will go to NPM to just try to verify, okay, it's version this, but not that. In this particular case, they left the changelog in the package, so it was easier to go, okay, here's where they are. We also are working on the research team on more sophisticated metrics to say package A and package B. Get me a score between them as to how close they are. Thank you. Other questions? Yes?
Yeah. With this and with PipeGuy, we're still seeing very basic inject a script at install time
Yes.
behavior. We've seen attackers go beyond anything beyond that, essentially.
Yes, well, in this case, dropping malware like this, but a lot of times the obfuscated code will contain layers upon layers upon layers of obfuscation. And so it isn't just that there's, like in this case, step one goes to run DLL and now you've got malware. It's usually peeling back all the layers, and at that time, whatever they decide to drop could do anything. But usually most of the things that we're seeing are stealing of some kind, whether they're credentials or cryptocurrency.
Well, I guess I'm asking if you've seen them do it outside of the install phase.
Oh. Yes, okay, that's great. So the question is, have we seen it done outside the install phase? Yes, there was a pair of packages that we saw last year. It was 2 clones of a cryptographic library. And in the cryptographic library, they were in 2 different namespaces, so they were not compromising the original ones, but they cloned them. And if you went to the bottom of these hundreds of files and looked in this 1,000-line file of all these cryptographic primitives, there was a certain function that had a little extra parameter passed to it that when your private key would pass through that particular cryptographic primitive, it would ship it off to a server in China. And it would just, so in other words, all the software actually did exactly what it was supposed to do, except that there was an extra line that said, HTTP .cn, and all of your private keys were being shipped off as you were using the software in the course of its normal use. Yes?
Given that this package was not downloaded or was downloaded at the current time, for example, how do you decide to examine this specific package?
So the question is, how did we find and decide to pick this particular package? So our platform It does have some sort of static string analysis type things, but really what we're looking for are behaviors. And so our platform flagged that this particular package had some behaviors associated with it, whether it was obfuscated code or whether it was a hard-coded IP address or some type of behavior is happening that our system flags, and then it gets elevated to my team. And for the most part, we review these to make sure that the rules that we have are not false positives or they have too high of a hit rate. But when a package like this comes through that we've never seen before, we'll usually do a deeper dive on it, and then we begin to pull out these attack patterns, these idioms. So for example, the pre-install script, run a file, delete that file. That's a common idiom now that once we see it, we can begin to train the system to go find those things. Great question. Anything else? Fantastic. Thank you for your time.